Welcome to Wildcat Science with Mrs. Helgo. This is Chemistry, Chapter 8, Section 2, Part 3. And we are getting into writing names for covalent compounds. So we are going to be just looking at simple binary molecular compounds. And binary, bi means two, so they just have two different elements. We're not really going to get into some of the more complicated ones. So first step, please write this down. You write the Greek prefix if there's more than one, and then you write the name of the less electronegative element, often the one that's more towards the left. So that's probably pointing this way for you. Then you write the Greek prefix if there's more than one, and then the root of the more electronegative element, which is the one that's usually found further to the right on the periodic table, and then you just use the root word and then you add the suffix IDE. So let's look at an example. Before we do that, we should probably learn our Greek prefixes, and then we'll do some examples. Okay, so Greek prefixes. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, which is a little bit more challenging one because you don't see that in geometry. 8 is octa, 9 is nona, and 10 is deca. We're going to have a quiz on these, so I would recommend starting to memorize these words. You should know quite a few of them already from life and from geometry. Now we're going to do our practices. So we look here, we start with the first one, and then the first one in the chemical formula is often the first one on the left, more left side of the periodic table. So you can double check that if you want to. But carbon, and there's only one, so we don't have to use a prefix. And there's 4 chlorines, so we use tetra. And then we just use the root, and then we use the suffix IDE. So carbon tetrachloride. So let's write that out. Okay, so we have carbon carbon tetrachloride. Okay, we'll do one more together. And so if we look here, we name the left one first, and then there's more than one, so we're going to use our prefix. And our prefix, we need 2 of them, so that's di. Okay, so we have di. Maybe we'll write it. Di, and then the word of the first one, the name of it, nitrogen, and then the root word of the second one, and there's only one of them, so we don't have to say anything, ox, and then the IDE, oxide. So dinitrogen oxide. Okay, then I have lots for you to practice, and we'll go over them in class. N2O3, the name is. N2O4, the name is. N2O5, the name is. So NO2, the name is. NO, the name is. S2F10, the name is. And our last one, SO3. Okay, I'd like you to pause the video until you have a guess on all 7 of these compounds. And once you're done with that, we're going to go the opposite. So given the name, we're going to come up with the chemical formula. So what you're going to do is you're going to use the Greek prefix for the subscript. So for example, carbon monoxide, well, carbon doesn't have anything in front of it, so we know it's just going to be C. And then monoxide, well, it means 1, so we're just going to write 1 oxygen. So this one is carbon monoxide. And we write mono because carbon dioxide is very common, so we're going to use the monoxide to differentiate it from carbon dioxide. Okay, I would like you to try an example, sulfur hexafluoride. So please write the formula for sulfur hexafluoride. As always, there are going to be exceptions to these rules. So what are the exceptions? Well, some of them are just specially named compounds. So this one technically is nitrogen trihydride. Nobody calls it nitrogen trihydride. Everyone calls it ammonia. So you just have to memorize that ammonia is NH3. Another one are organic compounds. So please write this down. So CH4 is methane, and your organic compounds has its own way of naming things, which we're not really going to get into this year. But if you take organic chemistry in college, you will be masters of it. And another one are your acids. So HCl is hydrochloric acid. We are going to get into our acids. So please write these down. Acids are a special class of compounds, and most acids are one of two types. You have your binary acids, and a binary, 2, is hydrogen and then a halogen. So we'll get into some examples of those. The second type are your oxyacids. So these are acids that have oxygen. So hydrogen, because it's an acid, and oxygen, and then a third element. Okay, so let's talk about the binary acids. Starting at the top of the column, HF is hydrofluoric acid. HCl is hydrochloric acid. HBr is hydrobromic acid. HI is hydroiodic acid. So those are the 4 binary acids I need you to know. And then there are some oxyacids. One of them is H2SO4. That is sulfuric acid. So you've got your hydrogen, your oxygen, and then your sulfur. Another one is hydrogen HNO3, which is nitric acid. Another one is H3PO4, which is phosphoric acid. H2CO3 is carbonic acid. HC2H3O2 is acetic acid. And it will make your life a lot easier if you know these acids. So we will be having a quiz. I need you to memorize these acids, and we'll have a quiz on it. I would like you to think through this list of binary acids and see what the pattern is in naming it. And then I would like you to look through this list of names of the oxyacids and see what the pattern is for naming it. Okay, the last thing we're going to talk about are chemical formulas for covalent compounds. So we're going to talk about the difference between a molecular formula and an empirical formula. So covalent compounds are different than ionic compounds, because ionic compounds, you just have a crystal, and it is like 1 million sodium ions and 1 million chlorine atoms. But the ratio is 1:1, so we write it NaCl. But there's never just like 1 sodium and 1 chlorine like connected together. It's always in this big old crystal. But it's little because they're crystals. And molecules are not like that. So you can have like the exact number that's in one molecule is different than the exact number that's in another molecule. So let's look at some examples. Please write this down. The molecular formula is the exact number and type of atoms in a molecule. Just to get used to how we write things in chemistry, they're usually ordered alphabetically. So for example, water is H2O. So H2O, whereas glucose is C6H12O6. Okay, so we can see that glucose is C6H12O6. They are alphabetical, and it tells us the exact number and type of atom. So in each glucose molecule, there are 6 carbons, 6 oxygens, and 12 hydrogens. If we were writing it in lowest terms, we would write 1, 2, 1, but that's not what a glucose molecule is. It's 6 carbons, 12 hydrogens, 6 oxygens. So what is it in lowest terms? That is called the empirical formula. The empirical formula is the simplest ratio of atoms in a substance. So like I said, in glucose it would be 1, 2, 1, C1H2O1. The empirical formula may or may not be the same as the molecular formula. It depends on what the substance is. So, for example, H2O is the empirical formula and the molecular formula for water. It's H2O, 2 hydrogens connected to 1 oxygen, and that is already in lowest terms. So let's look at benzene, C6H6, and I want you to tell me what is the molecular formula, the exact number, and exact type of atoms, and then what is the empirical formula, so the atoms in lowest terms. So I'd like you to fill that out, please. Boom, boom. Okay, we will go over your answers in class, and then in our next video, we are going to move on to 8.3, which is about intermolecular forces, the forces in between molecules or compounds with covalent bonds. I'll see you then.